problems are coming from the invited lecture. The Androids. So it can be a mixture of my style and their style, right? And anyway, we will have a midterm exam on class hour on Monday, next Monday. Also, where is your midterm presentation? Okay, 11/15 is project presentation. Okay, right. So midterm and then 3 weeks time. Right. Then today I will cover the section 2.2, and then Alessandro will cover. So there has been some jump around that because of my mistake of Tahiri's section. Okay, and then we will cover up to chapter 2 for midterm exam, right? And including the 2 seminars. Any question on schedule? No. Then I go on to this slide set. Okay. Reasoning. And chapter 2 is covering. And 2.2, right? Reasoning. But this one, contents is already covered at the beginning of this class, so we'll be short. Anyway, see that. Then the reasoning, there are 3 types of reasoning: deduction, induction, and abduction. And interpretation. Interpretation is related with deduction. Right? Interpretation. Interpretation of design or interpretation of language, sentence. Similar to deduction. Producing a design is similar to abduction. These are covered before. In deduction, Aristotle has a syllogism, and that is very similar to deduction. There are 3 components of case and rule and result, or similarly premise, axiom, and theorem, fact, knowledge, and inferred fact. The 3rd column is terminology coming from knowledge-based system or expert system. So it's an atomic, right? Atomic element for the other. Last week, Thursday, I covered that fact is made of object and relationship, and knowledge is made of relationship between fact and there is another control level, but here using these 2, we arrive at inferred fact, the new fact. That is true. And object and generalization and inferred fact is another. So interpretation, inferred fact, is a statement that is implicit in the given logical state. So implicit is reversed in other ways. Explicit, they are the other way around, right? So implicit is hidden inside some statement, or it can be a design drawing. So using design drawing, you can find out the performances of that design, engineering design. So syllogism is explained with this kind of diagram. You can think about set theoretical diagramming, set theory, set and element. So this is a house, the black dot. So, but house. So this is one case, specific case, right? The dot. House is a set, right? Set of this kind of items.
And all houses are building, so they are saying building, meaning of building is bigger than, larger than houses. So this point, the dot, black dot, this specific example is a building, categorized as a building. That is, we are saying syllogism. And induction, abduction. Induction is the process by which the knowledge component or rule, the theory of the syllogism is derived. So it is similar to learning. So through learning, you are creating, organizing knowledge inside your brain. New knowledge inside. So it's a baby, or as a student for learning Russian language, by learning, you create some knowledge structure inside your brain about Russian language. Right? So it's learning. The process by which theories are derived from the observations. So Kepler's, by observing specific cases, many cases, he found out some pattern out of it, some generality out of it. So that he explained, he represented that pattern, common pattern, into equation or theory, his theory. Components of syllogism in science, so observation and theory and prediction. Right? So by observing specific cases, he arrived at new theory of Kepler's equation. Right? And then using that theory, you can predict the position of the star after 6 months. That is also another deduction here. Using the case here, today I found that star, the specific star in this sky. Right? Using Kepler's theory, I can predict that the position of the same star, after 6 months. Prediction. Medical diagnosis. There are many symptoms. By using many tests. Nowadays, medical doctors use many test results. Right? Blood test, scanning, pressure, temperature, all the symptoms are together, and then he found out this is your disease. Right? And then after that, he can give us some medicine or operation or some treatment. So once again, this is Kepler's theory or equation, and orbit, planet's orbit. And 1 month later, but 1 month is different in positions. And 3 types of reading also again. Right? So Kepler did this kind of thing, right? So he observed many cases, stars, and also after 6 months, after 1 month. Right? So correspondence between these cases, and find out regular patterns out of it. That is a generalization of the cases. And using that case or rule, you can predict this star, the blue star. Today I observed here, using a Kepler's theory, you can predict the position of the blue star after 6 months. This one is already covered several times already. And abduction. Abduction is similar to design. So derivation of statement about the word. Statement. So creating a new statement, sentence of Russian language. Okay. How can you do that? I want to deliver my idea or my personal feeling to Russian friends. Okay. How can I make a Russian statement? Given logical rules, I should use the grammatical rules of Russian language and some logical consequences. The meaning I want to deliver as consequences. So it is very similar to a deductive system in backward. Right. So deduction and abduction. Or in terms of designing, engineering design, we start from required performance. That is similar to consequences. Right? And then arrive at statement or drawings or designs. And key reasoning mode operative in the design process. That is subduction. Question? Interpretation is similar to analysis and also deduction. And producing design is really similar to synthesis or abduction. Right? So design description. Design description can be a drawing or can be a CAD model description inside computer or paper drawing. Consists of statement, components of statement, geometry, attributes, relationship between components. That is design drawing or CAD model. Deduction as an interpretation. So interpretation is similar to deduction. Right? Interpretation, the analysis. Right? So derive attributes of the design. Attribute of the design. Attribute of the design. This is a design. Here's the fact. Right? Design. What can be the attributes of this design? Weight, cost, or hardness when I dropping, or sometimes I drop into the water is waterproofing performance. That is attributes of this design, which are not explicit in the description. When I give this to you, you don't know whether this is strong enough or it is waterproof or not. You should analyze. You should test to find out the attributes or performance of that design explicitly, not implicitly. Implicit is hidden inside. So the attribute is there, attribute is inside, but it's not explicit. It's inside, hidden. Right? So you should find out. So we need to have interpretive knowledge or engineering knowledge to find out the attributes. That helps us to make explicit in the form of logical. So interpretation is similar to deduction. But the other one is generative knowledge. But abduction is usually start in this way, in this reverse way, in this way, top down or but not bottom up, top down, abduction. Now let us see this one also. All right. So producing designs. How can you produce design for Indian ladies? Smartphone for Indian ladies for next year. Starting from performances, I want to make a good, very nice smartphone. I want to design, produce. Right? Good means what? But anyway, that can be a performance. We want to arrive at a description, the drawing or CAD model in terms of geometry and attributes and other performances. So that is very similar to abductive process. Designing, synthesis, and abduction. And then here, the interpretive knowledge can be used for the production, but in reverse way. Right? So deductive system can be run in reverse way. So we already see this picture already. Right? So abduction, we use interpretive knowledge, but the direction is reverse way. Backwards. Right. So I already done with this one. So I prepare because I already covered this one several times. So I find similar video script from the YouTube. And I hope you can do similar things in your lecture time, next time. That helps other students learning. Okay, how can I learn this one?
Inductive and deductive reasoning. Inductive reasoning starts with facts and details and moves to a general conclusion.
It takes 7
So
minutes.
it lists different details, different examples, and moves to a general conclusion or helps you come to a certain conclusion. Now, inductive reasoning is probabilistic, which means that it's based on probability. You hear certain facts and you come to a conclusion, and that conclusion is going to have some level of probability to it. Now, these conclusions can be strong or weak, and they can be proved false. You could come up with a conclusion that doesn't actually happen. It's not something that's true. But based on the examples you were given, or the facts you were given, the conclusion makes sense, even if it's not true. And that's how inductive reasoning works. So let's look at some examples. We have seen 30 white swans. Therefore, all swans are white. Well, based on the 30 examples that we've seen, this statement makes sense. This conclusion that we drew using inductive reasoning based on our 30 examples would make sense to build our conclusion. Next, let's talk about deductive reasoning. Deductive reasoning starts with a conclusion and then explains the facts, details, and examples that support it. So you start with one basic conclusion, one basic statement, and then give facts and details that can support it or that are examples of that statement. This one links premises with conclusions. So you come up with a certain premise, and it's linked to your conclusion that you started with.
Okay. There are many more you can find from YouTube. And also I found another one, this one, that gives you all the deduction, induction, and abduction together. I found that
Hey guys, thanks for tuning in to Management Consulting Journal again. And in today's video, we're going to talk about the differences between deduction, induction, and abduction. So just a quick note, all three methods are ways to logically derive at a conclusion, but they're different as well. So we're going to talk about that today. So in deduction, you have a rule, and then you see a case, and you think, okay, based on that rule, I'm expecting result X. So let's look at an example. So the rule could be that if prices increase, sales will decrease. And then we have a case where we launch product A at a high price. Therefore, the result is different from deduction and induction in that it looks at the result first, and then it tries to form a rule, and it checks the case to see if it conforms to that rule. So let's look at an example of this. The result that you see that sales have gone down, the rule that you try to apply is that sales go down when price is too high, and then you try to check the case. You check if price is too high on product A. If yes, then this rule is true. If no, then you throw out this rule and you start the whole process again. So abduction is the method that's most commonly used in case interviews. So you might see the parallel between this and the dress framework, where you observe the result is a problem that you observe, the rule is a hypothesis that you're trying to test, and the case is the key questions that you ask the client and the information that you get back. And so I hope that this series was helpful and you now understand the differences between deduction, induction, and abduction. This concept is very important.
all right. So Any questions? No. Then we can move on to lesson rules. And then discussion with Younggi, right? Do you want to use my...
Yeah.
Sorry?